Hello friends, today we'll be discussing two-dimensional arrays. So, as the name suggests, two-dimensional arrays have an extra dimension over one-dimensional arrays. So, in one-dimensional arrays, we only have rows. There is no scenario of a column. So, in a 2D array, we have rows as well as the columns. Okay, so in the 2D array, we can say that each element is itself an array. This simply means that we have a collection of single dimensional arrays stacked one over the other. It's a way of saying. It's not like hard and fast rule, but it's a way of saying. For example, consider this matrix. In this matrix, we have this single dimensional array, and then this single dimensional array, and then this, and then this. So we have many single dimensional arrays one over the other, so it forms a double dimensional array, right? We have the rows and the columns. Okay, so we can broadly say that rows are the horizontal part of the array of a two-dimensional array, and columns are the vertical part of the two-dimensional array. So the question is, then what's the size of this array? So we can calculate the size of the array by saying size of the array is the number of rows into the number of columns. That's how we calculate the size, by using the simple maths. For example, we have to calculate the total elements that can be placed in this matrix. So we can say that we can place 4 elements in each row, and each row has 4 columns, so we can place 4 elements also there. So we can have in all 4 into 4, that is 16 elements in the matrix. Here I have labeled the matrix. I have given the index 0, 1, 2 and 3 because it has 4 columns, so we'll number it from 0 to 4 minus 1, that is 3. And same goes for the rows. I have labeled it 0, 1, 2 and 3. There are 4 rows and 4 columns. Mind it that the number of rows or number of columns is one more than the largest index of the array. Okay, this is the way of writing. It's not like the thumb rule, but it's the way of writing that this is how our compiler accepts the array. It is inbuilt. Okay, so next comes the representation of array elements. So how do we represent the array element? Here is the technique. Suppose we have the array named ARR. Here is the array named ARR, and then I have 2 square brackets. The first one corresponds to the number of rows, and the second one corresponds to the number of columns. For now, from now on, I'll be using R for the number of rows and C for the number of columns. And with respect to C or C++ in Turbo Compiler, we have to write the data type of the elements of the array. So if our array has integer elements, the array consists of integers only, then we'll write int followed by a space, then the array name, followed by number of columns, and then the number of rows, and terminated by a semicolon. This is the notation. Okay, so guys, here the point to be noted is that these number of rows and number of columns, they're always constant. They're declared beforehand. For now, I'm using R and C, but I know that they're previously declared or initialized, or either I have asked from the user that how many rows or columns she or he wants to give, something like that. Okay, so next we see the creation of two-dimensional array. So for the two-dimensional array, how we'll create it, we'll just write We'll just write this that I have told you just now. The data type of the array elements followed by the name of the array. Name of the array could be anything. For example, ARR or simply array, followed by a number of rows and then the number of columns in square brackets. Okay. So that's how we write. Representation, actually I meant by representation like we have the array, something of this sort, a 3x3 array, or 3x3 array. Someone says, tell me the index of this particular element. This particular array element, as we know that we'll write the row first, then the column. So this is row number 0, and the column number 0, 1, 2. So this array element is nothing but ARR, row 0 and column 2. Okay, this is how we represent the array elements. Someone says that tell me the indices of this element. So we'll write this is array element present at the location second row and the first column. Okay, second row and the first column. This is how we represent an array element. Next comes the processing of the two-dimensional array. Here are the two ways. The row major and the column major. We can process the two-dimensional array row wise or column wise. I mean, if we have a two-dimensional array of this sort, we can either process it like first row, second row, third row, or we can process it column wise, like first column and then second column. It does not make any difference, but while printing the array, you can use either of the way. It depends on you, your convenience. I prefer row major over column major because I have the habit of writing in row major, but you may write in any way you wish to. So let's see row major. How to process an array using row major method. In row major method, we know that first we'll take this particular row and we'll process each and every element of this row. So we will use it. We'll use here a nested loop. Can you guess why? If not, then I'll tell you. We know we'll use a nested loop. For example, for loop, for, and then again a for. This much I know. I have to do this much. For within a for, nested loop. And then in the inner loop, I have to write the columns because for each row, I have to access every element of that particular row. So I mean, I have to go to every column of that particular row. So if we have a variable something, say I'll write I is equal to 0 since our columns are starting from 0, and I less than C. Why less than? Because I cannot be equal to C, because if we are starting from 0, then we have the indices 0 to C minus 1. So we'll have I less than C and then I plus plus. This part will handle my columns. This for loop will process my column for every row. And for rows, how many rows do we have? We have r rows. So we have the variable, say j equals 0 to j less than r and j plus plus. For r number of rows, I have to repeat this operation. That's how. Let's try to dry run it. For example, we have this array. This array has 0, 1 and 2, 3 rows, and 0, 1, 2 columns. So what are we trying? That corresponding to each row, we are accessing every element present in its column. Okay, so for j is equal to 0, j less than r, j plus plus. Initially our j is 0. Our j is 0, then we'll move inside. Our I is 0 and I is less than c, obviously. So we'll go inside and we'll process the information, whatever it is, and then we'll increment the I is 1, but j is still 0. If the array element ARR, R and C are mean, j and I here are processed, then j is constant at ARR, j is constant 0, and we are accessing 0, and then initially I was 0 and then now I is 1, then I is 2 and I is 3, depending on what type of how many columns are there, we're incrementing I, but j is same for this particular loop. So we can say that we are accessing every column of a particular row at a time, and then when this loop goes out of scope, loop does not go out of scope, or obviously the variable will go out of scope. When this I will go out of scope, j will increment and then will come inside the loop, and then again I is equal to 0 to I less than c, I plus plus will traverse I1 and then I0, 1, 2, 3 and so on, and then this process goes on. We'll traverse it like this. Okay, I think it's vague, but yeah, you'll actually grasp it soon. Then the next method is column measure method. In this method, we'll traverse the array column wise. So instead of having rows up and columns inside, in the nested loop, instead of having the columns inside the nested structure, we have the rows inside the nested structure. What I mean is, look, we'll have for and then this for inside a for. So I'm saying that in the inner for, you write the number of rows instead of number of columns. I'm saying I is equal to 0, I less than R, I plus plus. So this loop will take care of the rows, of number of rows. This will perform the operation at each row, but for a particular column. So we'll keep the column in the outer loop. That is j is equal to 0, j is less than c, j plus plus. So for each column, we are accessing every row element. So in a way, we can say that we are traversing the array column wise. We have the array. First we'll access this particular column, every row of this column, and then every row of this column. So this is column wise. Okay. Next we have the problem sum of array elements. Suppose we have to find the sum of all the elements present in a two-dimensional arrays. We have a very nice approach. First of all we'll see how to find the sum of the array elements in a single dimensional array. As you have seen, we have, for example, the elements 1, 2, 3, 4, and we have to find the sum of these elements. What's the approach? First we'll keep a variable, say sum equals 0, and then we'll say that sum equals sum plus 1. Sorry, yes, Here 1 does not correspond to 1. I mean this first element 1. Okay. Sum equals sum plus 1. Here we have sum as a variable because it is on the left hand side of the equals to operator, assignment operator I mean. So here the sum will hold the value. Initially sum is 0, so 0 plus 1, that is 1. Again when we'll call the sum, then sum will have sum plus 2. So we will have, here the sum is 1. So next time we'll have 1 plus 2, that is 3, and the process goes on. Similarly, in a two-dimensional array, if we're finding the sum of the array elements, we'll use again the nested for loop, because for traversing the array elements of a two-dimensional array, we don't have an option. We have to use the nested loop. So here goes the syntax part. For I equals 0, I is less than r, I plus plus. As soon as I write here I is less than r, so you have to think that we are actually traversing the array row wise, because for every column, for every row, every column is accessed. Okay. So here comes the body part. Here same, sum equals sum plus arr I j. So let's see what is happening here. When I is 0 and j is 0, then 0 and 0, first element of the array, and then j increments, I still remains 0, so we are accessing another element, then another element. We are accessing the first row. So the sum calculates the sum of the first row, and then will increment the I. Then we'll similarly calculate the sum of the second row, the third row, and how many rows we have. We'll calculate the sum of all the rows, and then finally we'll print the sum. Let's see, we have cout sum. After this for loop, after this for loop, for inside a for, we'll cout the sum. In C++ only we use cout. Then what's the sum is? Sum of every array element. I mean sum of the whole array. Okay. So the next question comes is, what do you think, how much storage is required to store the two-dimensional array? Any idea? Amount of storage required to store the two-dimensional array. Let's see. As we have seen, the size of the two-dimensional array. What was the size? Size was number of rows multiplied by number of columns. So the size of the two-dimensional array is actually the total elements that are present in the array. Okay. So if we know that each element occupies x amount of space, then we have the total number of elements. We will say the total number of elements multiplied by x gives the total amount of storage required to store the entire array. Okay. So for in case of integers, I mean the int data type, in Turbo C we have this int as 2 bytes. It occupies 2 bytes in the memory. So for an integer array, say integer arr 3 and 2, I mean 3 and 2 means 3 rows and 2 columns. We have the amount of storage required to store the array as 3 into 2 into 2. Here 3 is the number of rows, and this is columns, and this is the number of bytes that is required to store the data type. So we have this, this is 12. So we have 12 bytes. 12 bytes are required. In case we have here float Then here we have 4 byte. 4 byte, I'm telling this data according to Turbo Compiler. This data may vary from compiler to compiler, but the concern is the concept. I'm not interested in the data. We're actually interested in just the concept. So here comes the data as 24 byte. Okay. So let's see one more problem. Here we have to check the quality of the matrix, whether the two given matrices are equal or not. Okay. So guys, if we'll check the equality of each and every element, instead we should go for inequality of each and every element. I mean, if even an element will be unequal, then we'll say the whole matrices are unequal. Instead of checking for each and every element whether it is equal to another or not, we'll check as soon as we get the unequal element, we'll come out of the scenario and we'll just print it off like they're unequal. Okay, so let's see. What's the approach? First we'll input the input matrix 1, okay, then input matrix 2, and after inputting, after the user has given the input for the two matrix, then we have to check whether they are equal or not, or else we can say whether there exists an element that is unequal. I mean, there should exist, or there may exist at least an element that is unequal, so the matrices are unequal, otherwise they are equal. So we'll check for inequality. These are the 3 steps or methods that we are following in this particular question. Okay, so first step is, first we'll input matrix 1, and I have forgotten the last step. The last step is, after we have checked for the inequality, we have to print whether they are equal or not. So this is a part of this inequality, but we'll explicitly print if equal or not. For inputting the first matrix, we have the nested for loop for I equals 0, I is less than R, I plus plus, and then for j equals 0, j is less than column and j plus plus, and we will simply cin arr I and j. Okay, this is how we'll get the first matrix. Same goes for the second matrix. Okay, so second matrix is, suppose the first matrix, here we have considered the name ARR, here we consider the name ARRAY. For the second matrix, we say for I equals 0, I less than R, and then I plus plus, then for j equals 0, j less than c, j plus plus, c in ARR, AY, I and j. From this part, we'll get the second matrix. We have the two matrices with us. Now we have to check if there exists at least an element that is not equal to the next element, to the corresponding element of the matrix, of the next matrix. So here we go. For traversing the matrices, we always have the nested for loop for I equals 0, I less than R, I plus plus, and then for j equals 0, j less than c, j plus plus, and then here we have the main procedure. If ARR of I and j is not equal to ARR AY IJ, then we'll simply break. This break, okay, instead of having a break here, let me introduce to a new method. For example, if we have a new variable int flag equals 0 outside the loop, so we'll make the flag equals 1 as soon as we'll encounter this inequality. So we'll check after the exiting of the loop, we'll check whether flag equals 0 will print equal, else will print unequal. And here is your solution. Because I have not used break here, because break is used inside a loop. Okay, so instead of using a break, I have used the flag variable, which actually increments its value. I mean, it changes its value as soon as the inequality is encountered. So after we have done with the iteration and all, after we have checked